Sure.
Hi, my name is Bhekuzulu Khumalo. At the beginning of 2012, I wrote an article called "The Derivative in the Third Dimension" for Global Journal of Mathematical Sciences, Theory and Practical for this journal. In 2011, end of 2011, I wrote a paper called "The Mathematical Infinity and Economics" for a journal belonging to the International Atlantic Economic Society, a joint European and American journal. What I'm about to talk is an extrapolation from those papers. We recently heard about CERN, a project in CERN, where we saw neutrinos go faster than the speed of light, and then they said, no, there was some calculation malfunctioning. Can matter travel faster than a speed of light? And we're going to look at this from a theoretical point of view, extrapolating from those papers. Now, for us to understand and get to the point where we tackle can matter travel faster than the speed of light, let us start with a simple concept. Take a straight line. A straight line can be divided into infinite parts, and we must ask ourselves why a straight line can be divided into infinite parts. The reason is because a straight line is one-dimensional. You cannot, however, divide a human being or an atom into infinite parts. Because once you cut a human being in half, it's a corpse. Once you cut an atom in half, it becomes something else. Like if you cut gold in half, it becomes something like zirconium. Because it will have half the protons. It will no longer be gold. So now, this is because these are three-dimensional properties. And we must take the calculus that was derived by Bhaskara, an Indian. Notice, Bhaskara was an Indian. Though in history books you hear it was Newton and Leibniz who discovered calculus. No, it was discovered by Bhaskara 500 years before Newton. And Newton himself discovered it 30 years after Leibniz. He stole Leibniz's work and claimed it as his own. But that's part of history, and this is not about that. We have to change the calculus, the rate of change, to suit the dimension of variable. Let's take knowledge as an example. To understand knowledge, you've got to give it a unit, to understand it scientifically. Or it is not possible ever to understand a concept like knowledge. That unit we gave knowledge is called a knowl. A knowl is a unit of knowledge. I'm not going to go into the details of it right now. But we now know that we take a knowl. You can add it. One knowl plus one knowl will usually equal two knowl. But whenever you add knowledge, it's not always going to give you 1 plus 1 equals 2. In many instances, it can give you 1 plus 1 equals 1. And that is a fact. If, for example, you know, the only thing you know in this world is that 1 plus 1 equals 2. And the only thing I know in this world is that 1 plus 1 equals 2. So my one knowl is 1 plus 1 equals 2. Your one knowl is 1 plus 1 equals 2. When we add our knowledge together, we will still have one knowl. Because we will both only know 1 plus 1 equals 2. You can't add the same thing with knowledge. Why is that? That's because knowledge has a peculiar quality. It both behaves as a three-dimensional variable and an infinite dimensional variable. When you add 1 plus 1 equals 2, that is behaving as a three-dimensional variable. And 1 plus 1 equals 1 is behaving as an infinite dimensional variable. Now, you cannot take that calculus that was proponent of Newton and Leibniz. You can't take that calculus and say 1 plus 1 equals 1 because the rate of change is 0. But that calculus cannot confirm that. It can't deal with that. So you've always got to adapt calculus. And the higher your dimensions, the less your rate of change. So a one-dimensional variable will change at a seemingly quicker rate than a three-dimensional variable and a four-dimensional variable. So if, for example, you are dealing with 7-dimensional variables, 6-dimensional variables, and you're using calculus as expounded by Newton, Bhaskara, and Leibniz, you'll never get the answer, and you'll never understand that 6-dimensional variable. Because you'll never understand the rate of change you're looking at, but you'll see it and say, no, it's not possible. But you've got to change the rate, the calculus, to suit that dimension. So 1-dimensional is the greatest change, infinite the least change. With infinite dimensions, there's 0 change. Always 0. And you've got to take out, for each one, you've got to take out the information presented. What does this mean? This, obviously, if we extrapolate, it means that the rate of change is narrowing more and more the higher dimension. How does this affect, why then does this affect the speed of light or the rate of change? Let's take 2 tennis balls. Let's pretend this is a lab. This is a lab. Here's a tennis ball. We throw this tennis ball, and let's say this is 20 meters, and the tennis ball travels at 20 meters per second. So it will go from here to here in 1 second. Let's pretend this is a highly magnetized field in here. And in this highly magnetized field, we have got higher than 3-dimensional. It's many dimensions, let's say maybe 7 or 8. And you throw a tennis ball in fast. There's this one outside and this one inside. They're both traveling 20 meters, but in a higher dimensional field, this tennis ball will get here before this tennis ball. You've got to understand, because of the dimension. But the tennis ball is going at 20 meters per second. Okay, let's say this is a car. This is 200 kilometers. It's going at 200 kilometers an hour. It will move from here to here in an hour. In this high dimensional field, it will move from here in less than an hour because the dimensions are higher than four dimensions. So the car will move, and it will arrive here fast. But for the man inside looking at the speedometer, even though he was in a higher dimensional plane, the car, he only saw 200 kilometers an hour. But to a person outside, it would look like it's going faster than 200 kilometers per hour. So now let us take space travel. Because we cannot take this into space. We take this and we build it around. Let's pretend this is a spaceship. Now, here's our rocket. It goes from here to here, and that's the moon. The rocket will move from here to the moon. It will take 3 days. Now we've taken this thing from the lab, this higher dimensional field, and built it around so that we have a bubble around the spaceship. The spaceship will move from here to the moon in less time, theoretically, than this spaceship. Theoretically, but the maths says it has to get there before this other one. So they both leave Earth, let's say Cape Canaveral, and they're going to the moon. Both rockets leave Earth, but this one is in a bubble of higher dimension. It will get to the moon at a quicker time than this one. So now that comes to our question at CERN. Why were people seemingly seeing neutrinos go faster than the speed of light? At CERN, you've got the largest particle accelerator in the world and the most powerful. So what's happening in there are things that people probably don't understand. Probably some of the neutrinos would get caught up in a bubble. Inside that bubble, they are still going at the speed of light. But to the person outside, it will seem as if they're going faster than light. Because nothing can go faster than the speed of light. But inside the bubble, it would look as if it's going faster than the speed of light. So it is possible, theoretically, in a higher dimension, to similarly for us in a 4-dimensional plane, to look at something that goes faster than the speed of light. I can guarantee this. If we go to a lab today, in a highly magnetized field, where the dimensions are changing, very powerful magnets, and we throw this tennis ball, it will go faster than the tennis ball outside. Because of the dimensional field. Not any society can do this. And, science is not about it seemingly of what, it's about wanting to know things and extrapolating our knowledge. Here we're moving from the maths and then extrapolating it to other things. You can't say you want this, and then you extrapolate backwards, and then you say the machines were wrong. No, the machines are not wrong. You didn't understand what was happening, and now you understand. Yes, you can travel at the speed of light, but for you sitting inside that bubble, you'll never be going faster than the speed of light. That is the only way we will ever move from this world to this world. And if once you do that experiment, in 50 years' time, we will start traveling. Now to more serious issues, because I do prefer light economics. This is something that I bumped into with the math because I gave knowledge a unit, the node, and then I understood that calculus has to change, otherwise it won't account for the different dimensions. I'm going back to my serious thoughts. There must be equality before the world. That is when we will have the greatest knowledge base in this world, when there's equality before the law for all human beings. Thank you very much for listening. See you later.